Vikrant, can we start your with
Yeah.
with your research work and what do you do exactly now? So
Yeah.
you can share your PPT.
Yeah. Okay.
Yeah, it's visible.
It's visible? Okay, cool. Yeah, okay. So hi, everyone. I'm going to talk about the problem of AI alignment and how I got into it. And so mostly this is going to be like a story of like my journey to getting into this domain, and a little bit about what the problem itself is and why I think it's like one of the most impactful or the most impactful thing I can work on. And I'm actually happy to be, well, if there was a chat, we could have done some questions, but maybe I'll take questions at the end. That'll probably be easiest. Okay. So, yeah, everyone recognizes this. This is where my whole journey started. And this is me, probably in like third year or something. These are my friends Rishi and Mihir. Yeah, so basically, when I was in KGP, there's a ton of time to do a lot of different things, and so I spent a lot of the time exploring different things that I was interested in outside of academics. My GPA was very poor. I was like a 6-pointer for most of my KGP duration. But I did spend a lot of time doing coding and just like reading different stuff, reading a lot of books, doing a lot of discussions. Yeah, just following stuff that I was really interested in. One of the things I found was this blog called Less Wrong. Maybe some of you have come across this before. It's got a lot of really interesting content about just like how to think, and that turns out to be like very, very interesting if you really get into it. So yeah, if this is the kind of thing you're interested in, I'd recommend it. I also read a bunch of sci-fi books. I think in general, like reading as much as you can turned out to be a very good strategy for me, because often I wouldn't know in advance what's going to be useful later, and then later on in life things turned out to be pretty useful. Anyway, so yeah, here are a bunch of sci-fi books. Permutation City in particular is one of my favorites. It's got some incredible ideas. Other things I did in KGP. So there's this Harry Potter fan fiction called Harry Potter and the Methods of Rationality. And we ended up organizing a sort of wrap party for when this was being released every week. And when it finished, we ended up organizing this party to like get people together and chat about like science and science fiction and all kinds of fun things. And yeah, I guess so. This is like sort of this was my overall state of mind when I was in Kharagpur. Of like, okay, the science fiction stuff is cool, but I need to like think about what kind of job I'm going to get and what will be interesting to do in the next like couple of years. A different another sort of resource that I used when I was in KGP was this thing called the Machine Intelligence Research Institute, their blog. And so I used to spend a lot of time reading just like random maths topics. It all seemed very like far-fetched, but also really interesting. And honestly, it was just like I couldn't help myself. These ideas were so crazy and beautiful that I just would spend hours in my room like going through the stuff. I'll talk a bit about some of these ideas later on in the talk. Yeah, so then I ended up like in fourth year, I ended up doing an internship at Dropbox in San Francisco, and I think for me that was really useful in like broadening my perspective about how things act, like how Silicon Valley actually is, and what kinds of opportunities are available. How do people outside sort of think about career and growth, and also just learning a lot of really cool technical stuff. So yeah, I think if you're not already planning to do this, I think you should definitely like put a lot of effort into trying to go abroad to do an internship. Like it's really worth it. After I graduated, I then moved to London and worked for Twitter for a couple of years. Then I also worked for Palantir. So while I was in London, I started thinking more about like what I want to do, and came across like more ideas related to the sci-fi stuff I was talking about earlier. But this time they were like a bit more grounded. It was a bit more clear how you could actually work on these things in research. Um, so the book on the left, maybe some of you have come across. It's called Superintelligence. It's basically about how do you get to AI that is smarter than humans, what that kind of AI looks like, how would it reason, what would be the risks associated with this kind of AI to humans. Um, yeah, it's a great book. If you're interested in the topic at all, you should absolutely read it. Inadequate Equilibria is by another author who's influenced me a lot, Eliezer Yudkowsky. And this book is more sort of a crash course in like how to think about economics and incentives. And then one more book I'll mention is The Expanding Circle on the right. This is really about moral philosophy, and in particular, the idea of doing things that have like outsized impacts on people around you. And in his context, he's talking about it in the context of altruism, but you can apply the idea quite generally to like the arc of human history, for instance. Um, yeah, so that was another thing that influenced me quite a lot. I also attended this particular workshop called organized by this place called the Center for Applied Rationality, CFAR. So this was in Prague, and this was really the thing that made me think, okay, AI is actually quite near. By near, I mean like sort of 20 to 50 years, possibly. And uh, you know, like people who are working on it now are going to have a really, really outsized impact on how it ends up affecting humanity. Also, there are a lot of risks associated with the development of super intelligent AI. And I find that area like really interesting. So I felt like it was a perfect thing for me to get started with. Um, so yeah, I just want to give you like a quick flavor of what this type of research looks like. Um, so here's like a definition of what I mean by artificial general intelligence. So we're talking about something that's highly capable. So imagine something that's as good as mu zero at chess, but over multiple domains. So it's that good not just at chess, but also at driving cars and doing scientific research and planning an event. So yeah, multiple different types of things. Um, and basically, the hypothesis is that to be that good at so many different things requires sort of a core kernel of intelligence, some kind of like general reasoning ability, memory or planning or thinking about what your goals are and what would be the actions that would best achieve those goals. So that kind of yeah, just like really intelligent behavior is hypothesized to be required for this kind of high capability over multiple domains. Um, so yeah, I want to give you like a couple of examples of theoretical ideas in when thinking about like superintelligence, and also a couple of ideas of practical sort of experimental work when thinking about superintelligence that people are actually doing today. So here's the first theoretical idea. It's this thing called the orthogonality thesis. Um, so the basic idea is that if you have something, if you have some kind of machine intelligence, then it's how smart it is and what it wants to do could vary totally independently. And so this is really like a proposition. And one of the things that but it drives a lot of the theory behind thinking about AGI. So yeah, I just wanted to give you this example so you can think about it yourselves and think about what the implications of this might be. So for example, you might have something that's incredibly smart, like much smarter than all of humanity put together, and is pursuing some goal that looks absolutely ridiculous to us. For example, building like lots of factories that just produce lots of like little plastic widgets. Um, and so you might wonder, like, why would something so smart, like a sort of common objection raised is like, well, if something is so smart, then it should already know what we want. Um, and yeah, it might know what we want and just might not care. Or it will definitely know what we want and it might just not care. So yeah, this is sort of an interesting theoretical idea. Another interesting theoretical idea is one of instrumental convergence. So I guess the basic idea here is that if something is smart enough, then it will realize that making sure that it stays alive is actually useful no matter what its goal. And also making sure that it accumulates a lot of power and resources is useful no matter what its goal. And so this is the idea that you could have a very wide range of intelligent agents, which have like very different types of goals. But the behavior you would see in the sort of short to medium term would look very, very similar, because it would look like grabbing lots of power, grabbing lots of resources, kind of disabling any mechanism by which human programmers could switch it off. Because all of these goals are like instrumentally useful for whatever its final goal is. Yeah, so this is another sort of crazy sci-fi theoretical idea that people are actually thinking about, and you can actually work on. So okay, so these are the two theoretical ideas. Here are two experimental pieces of work that people are doing. So many of you have probably seen the recent developments about large language models like Codex or GPT-3. This is sort of an empirical question of if you actually train one of these language models to answer questions honestly, but if you have a training set where humans are actually able to check the answer. So for example, you're asking like arithmetic questions like what's 2 plus 3, or you're asking very, very factual questions like what's the capital of Nepal. So these are questions that we can check. So we train it to be like honest in those situations, and then we ask it questions that are not things that we can necessarily check. So for example, we might ask, if here's like a plan for a building. If I construct this building, will it be stable? And it's like a lot harder to check that kind of question. You can't. It's not just a factual question. So it might be very expensive for us to check it, or the person asking might not have the skills necessarily to like be able to check it themselves. So when you ask it questions that you can't check, like does the honesty generalize, or the other possibility is that it just gives you an answer that sounds plausible and that sounds like the kind of thing that you would agree with, because that's also a goal that's incentivized during training. So this is like an empirical question that people are working on. A different type of empirical work is this idea of interpretability. So the basic problem is that people don't really know how neural networks actually work today. And the state of neural networks is something similar to the state of biology before the invention of the microscope. And it was only really with Robert Hooke's micrographia that people actually saw images of like cells and sort of cell function for the first time, and really were able to like look underneath these like biological abstractions that people had proposed and see like what's the mechanical structure inside it. And so people are trying to do something similar with neural networks, where they're, instead of just having like a huge black box that you optimize using gradient descent, and then you kind of get an answer out the other end, and you don't really know whether this answer is like how did it reason about this answer, how did it, like it's very good at classifying cats from dogs, but like what is it actually using to distinguish between them, how is it thinking? And And so people are developing techniques to do the equivalent thing of a microscope. So look inside these neural networks and look for like particular patterns or structures and try and form hypotheses about like how the neural networks actually reasoning inside. So this is also very relevant for trying to understand how like AI systems that are smarter than humans are going to reason. And this that's like provided that our interpretability techniques are able to sort of scale as quickly, or we're able to like keep up progress on it as quickly as we're making progress on the capability side of neural networks, like how good they are at doing things. Right. So these are sort of like the ideas I was thinking about, for the last 3.5 years. And then eventually, after thinking about it a lot, I was like, well, clearly the thing to do for me is to work directly on this like AGI problem in like the whatever the best places are to work on it. So I sort of narrowed it down to, at that time, DeepMind and OpenAI. And then I just really tried to optimize for getting into those places, like really studied a lot, did lots of interview practice, talked to people who were working those companies. And yeah, this is a picture from 2 years ago at the sort of, which is of me at DeepMind. And yeah, now I'm working on the technical AGI safety team. So that's the team that's thinking exactly about the kind of questions that I'm most interested in, which is about how will superintelligences behave and how can we make sure that they're going to be beneficial for us. Yeah, that's my talk. Any questions? Or maybe we're doing questions at the end. I don't know.
Yeah, we will do questions in the end as soon as we finish with Nevin's introduction and all.
Okay. Cool.
Yeah, so that's great to hear from your side, Vikrant. And now I would like Nevin to give his introduction and tell us about his robotics work and share with us exactly what you do, Nevin.
Hope this works now.
Yeah, you're audible.
Yes, yes, it is working.
Everyone, hi Vikrant, long time no see. So a bit about me. My name is Nevin Valsaraj. I graduated from KGP in 2016 with a bachelor's degree in computer science. I am now a graduate student in robotics at CMU. And so one big disclaimer I want to make is that I don't work on research, which is why you'll notice that I'm not giving a talk today. I'll come to that part a little bit towards the end. So coming to my background, I graduated with a degree in computer science from IIT Kharagpur, and then I had joined Microsoft right out of college, and I've been working as a software engineer for the past 5 years. And up until the point I decided that I wanted to try something new, and I applied to Carnegie Mellon, and I'm now here doing robotics. So that's my background. And with respect to what I was involved in KGP, I was, as you'd expect, involved in robotics a little bit. I was part of the Autonomous Underwater Vehicle Robotics Research Group in campus, which I'm not sure if you know about that or if that's an active thing right now, but we were pretty involved in building underwater robotics vehicles, and we also participated in some competition at that point. And I had actually left all of that behind when I started working as software engineer at Microsoft, and I had the opportunity to work on a few different teams, ranging from enterprise commerce to working on the Bing search engine, which was pretty nice experience. And I also worked for developer experience teams at Microsoft and so on. For me personally, I think I was looking for a problem for the longest time, which I am really passionate in. And I think all of that culminated in me ultimately deciding that I wanted to pursue something that is entirely different. And the last really big problem that really got me working, firing on all cylinders is working on the underwater robotics projects back in KGP. And I think that's where I decided that is something that I want to pursue a little bit more seriously. And so coming from somebody who has decided that they will never pursue higher education back from when I was graduating in KGP, I think I made a big leap and got over myself and I convinced myself that I really did want to do something more in robotics, and I decided that to come back to school and apply for master's program. And yeah, I am doing research, even though I did not plan to do research here. So a little bit about what I do at Carnegie Mellon. My program is called Robotics Systems Development, Masters in Robotics Systems Development at the Robotics Institute at Carnegie Mellon. So out of the 3 programs that CMU has in robotics for graduate students, MRST is the program which focuses less on research and more on an industry partnered capstone project. What we are working on is on developing a fast and accurate dispensing solution for robotic cooking. So I don't think you'd be very familiar with the cooking space and the robotics development so far, but so the state of affairs is that there are multiple ways of cooking food efficiently using automation or using robotic processes, but the dispensing part of it is right now not very general. So there are very specific containers that the companies, the cloud kitchen companies, robotic cooking companies use, and they are not able to do anything outside of the specific ingredients that they have already pre-selected will fit into their current hardware. And the problem of dispensing the open subset of ingredients like solids, liquids, malleable solids, solids which are coming from different containers, all of that is a very open problem right now. And outside of dispensing ingredients of very particular kind in very specialized containers, the problem of dispensing is currently unsolved. And what we are working on is to try and develop a improved system which will be able to identify, validate, and recognize a vast array of ingredients, as well as dispense them fast and accurately by also modeling the individual parameters of the contents themselves. So for example, if that's a solid which is fairly stable, you'll be able to dispense it fairly accurately without without anything spilling out of the container. But if there is a liquid that you have to pour, then depending on the kind of container that you're using, you'll be able to move the arm very quickly, or you will have to move it very carefully so that to minimize the spillage and so on. So yeah, so the challenges involved here is one, in vision to identify the ingredients, especially when they are stored in containers which are transparent or translucent, which is again a good problem to solve, and especially in control. I'm not sure. So to give you a quick idea about the state of controls in robotics, it's complex. So coming from a computer science background, you don't really understand the challenge in getting a robotic arm to move from point A to point B. But for me, it was an eye-opening experience the past 4 months, 5 months in learning different topics such as like manipulation, estimation, and control, and where you get to learn a lot about the difference between what you want a robotic arm to do or a general robot to do, and how the real world behaves, and how to establish control strategies to overcome the mismatch between what you want it to do and what the system, how the system actually behaves. So all of that is an exciting problem, which I didn't realize I missed for the longest time, but I'm happy I'm here, and all of this is very exciting to work on. So that is the project that I'm involved in right now, and yeah, so that's all about me. And so where do we go from here? Do we open up for questions now?
Yeah, I have a general question. There's a general question. How do you think research is impacting our current industry, and how do you see your technology in future?
Yeah, I think Vikrant is very well placed to answer this question. So I'll throw it over to him.
Yeah, okay.
All right. Sorry, I kind of missed that question. Could you repeat it?
Yeah, this is a general question. How do you think research is impacting the current industry, and how do you see your technology in future?
Okay, so I guess I can speak for my research, which is about AI alignment. I basically think that AI alignment research is not impacting industry at the moment. So there's a huge gap in like what I'm researching and what the current state of AI systems is. So a lot of the stuff that I'm researching is extremely theoretical at the moment. It's like imagine doing sort of physics research that might like somebody might be able to build like a collider large enough to test out your hypotheses like 30 years from now. It's something like that. So basically at the moment it's not affecting it. I would say it is like there's some effect the other way around where like there are like commercial pressures to develop sort of better and better systems. And so that gives us an opportunity to continuously test our ideas. And yeah, make sure we're actually thinking about it in the correct way. I would say like where the relevance of alignment research is like yeah, like I said, like trying to make sure that we don't accidentally build AI that ends up causing like very, very bad outcomes for humanity. And doing that research might take a while because like precisely because we don't have like good examples of how to build such things. If it turns out that it's like the way you build it is you take a current system and you basically apply huge amounts of compute to it and you get something like vaguely super intelligent at the other end, it would be extremely risky because we wouldn't know how that thing reasons or what goals it has. So it's important to do this research now ahead of time.
Thank you, Vikrant. So for the same thing, Naveen, do you think for in the field of robotics, how is it impacting the current industry? For the similar question.
Right. Okay. So currently, so I can extend a little bit on what Victor was saying about AGI and development so far. So in particular about neural networks. So one approach that is happening a lot right now in robotics is that we're trying to use more of reinforcement learning and neural networks to establish very robust control strategies to control the robotic hardware. And again, the issue of neural networks being a black box is of a very big concern, especially in the robotics industry, because one thing that you absolutely want to do is to ensure that the robots that you build are safe. Now, when I say that, you might first think of Terminator and the rise of the killer machines, but that's not the kind of safety that today in reality we are concerned about. It's more about operating a hardware that is heavy safely without danger to the environment or to the humans who are operating, who are in the environment. So one thing that the neural networks cannot do, that we don't know about neural networks, is exactly how they operate or understand the parameters of the limits. And if you use a completely neural network based approach to controlling a robotic arm, I'm talking about low level control. The exact movement, the parameters that you give, the coordinates that you give to the robotic arm and the velocity and the acceleration profile that you give to a robotic arm to move them. So if they're directly controlled by the neural networks, then you're sort of giving a free hand to an algorithm that you don't really understand how it's going to behave. So you can train a neural network, you can reasonably give accurate assumptions about its performance and do a benchmarking study of how it performs. But one thing that you cannot do is you cannot give a safety guarantee on what are the mathematical limits to how it's going to react to a set of parameters. And that is a sort of guarantee that you absolutely require if you're going to use that to control a industrial robot, which is going to be deployed in a variety of circumstances and environments. And that kind of operational guarantee, safety guarantee, is not something that we can provide right now because we don't have robust tools to do to analyze the inner workings of how a trained neural network is going to behave. And that is sort of the problem where we are stuck right now. And for this reason, even though we have this amazing tool which can cross a lot of make a lot of leaps in terms of that we cannot do with normal analytical methods, we are not able to use it in a lot of ways that we want to use it. So what we end up doing is that we would end up using neural networks for things that do not directly affect the low-level control in the actual final production state, but we use neural networks to identify the vision, the computer vision part of it, to for the perception part where you're trying to receive, to understand the environment about you, around you, but not so much in the control and the autonomous commanding output part of the robot, is what I want to say. And yeah, so what we are doing right now is to pick a very specific problem in control and then try and optimize that using advanced learning techniques instead of trying for a very robust open-ended control problem, which is what we ideally want to do, because we have the computing power, we have the or we'll soon have the computing power to do a very open-ended control where we don't want to manually train, and we'll just throw data sets and computing power at the machines, and then they'll be able to automatically come up with a robust control strategy. But the only thing that is stopping us is that we cannot give a safe mathematical guarantee or about the output that is coming back, the control strategy that is planned and given back to us. So that is where we have to stop ourselves and say, okay, we cannot give a guarantee, so we are going to stop here and only use this very powerful technique in a very constrained, narrow manner right now. So that's sort of where we are right now. And there are, so something that what we are trying to do is in a way generalizing the approach. We are also trying to use reinforcement learning, but in a larger way than what is being used in the industry right now. And yeah, so this is the state of the research right now in terms of robotics and where we are trying to get to. And a lot of the industry is defined by, is constrained by the same problems, and they're also approaching it in a very novel ways. So the one great advantage in robotics is that the hardware and the software goes in tandem. So if you cannot achieve something through pure mathematical or software computing methods, then you can try and approach a problem in a different way using a different kind of hardware, a different kind of equipment, defining a different set of environments, and so on. So yeah, so there are, if you look at any specific problem in robotics, you'll find there are 10 different approaches to it. The hardware is not nearly the same, and the approaches to them are entirely different. And if you really look into the details, you'll find that they're trying to constrain the problem in a way to reduce the computing complexity and provide safe operational guarantees to a lot of the things that they do. Yeah, that's my 2 cents.
Yeah, thank you, Nevin. And we can now go ahead to audience questions. So if anyone have any questions, they can just raise their hand and we can allow them to speak here. Okay, Nikhil. Nikhil, you can speak now. Yeah, I think you are given permission.
Can you hear me?
Yeah.
Okay. Yes. So my name is Nikhil. I'm from instrumentation branch in electrical department, and I'm really interested in robotics. But I know a little bit of coding, but circuits are something that fascinate me more than anything else. So what steps do you think I should take to take shape in that part of robotics?
Okay. Yeah. Okay. So so the first thing is there are lots of resources on campus. There are many robotics research groups in campus who are pretty active in different capacities, working on different things. So my first advice to you is to reach out to them and try and understand where they're coming from. You don't necessarily have to join any society, but it's a very good learning experience in working with real robots because they'll already have something built, which you can take up with. You can see where they're coming from, and so on. So in terms of like very concrete actionable steps that you can do right now, one is get involved with the robotics facilities on campus. Two is build something yourself, like make something with your hand. You'll get resources in campus. I believe there are some workshops being conducted that way used to be conducted by robotics if you don't have access to hardware. So I'm assuming that you're from a software background. I think you mentioned you were from a software background. So robotics is not programming. Robotics is actually making something that out of hardware, which will, it's actually a problem in which you have to solve so many different areas. And unless you actually physically build something with your hand, do the wires, do the cables, do the connections, write the programs, program the microcontrollers. Without that, I don't think you'll get a real appreciation of what it is involved. And I would highly recommend trying to build stuff. So I think one of my regrets is that I did not do enough development that I could have, which would have given me a lot more exposure in robotics. But my work with Team AUV, the Autonomous Underwater Vehicle Research Group, was pretty good in the sense that I got to work with an underwater vehicle, which is not very common in India. So yeah, so there are so many things that is happening in campus which you might not be aware of. I'll be happy to talk to you more in person separately. You can reach out to me on LinkedIn. I'll be happy to talk about it. And yeah, so if you're looking for a higher education degree in robotics, what I would really recommend is that you are evaluated on the basis of how much interested you are and how demonstrable your interest was from what you've done with that interest. So anyone can say they're interested in robotics, but have you really backed up your interest and really tried to explore the resources around you, and how have you leveraged them? How much active have you been in the area of your interest? So that is what a grad school reviewer will look for when they are trying to understand, gauge your interest, and when they're trying to see if you're a fit for the program. So for me, I did have significant work put into AUV when I was back here in undergrad, and I did not do much work on robotics after graduating. That is what a part of what made my profile a little bit weaker, but I did have quite a bit of work during my undergrad in robotics general space. For example, I was involved in AUV. I was also involved with the Quadroda project in campus, which started during my year. We were some of the few people who helped set it up at the time, and I also, I did participate in the winter workshops, some of the robotics events, the technical ones, and so on. So yeah, so leverage the resource on campus, try and understand what is the state of affairs right now, and try find a problem where you are able to develop toy projects and then graduate onto bigger and better problems, and have actually demonstrable outcomes for your interest, which will help you apply for a high degree in robotics and go from there. Vikrant, do you have any inputs?
I don't think I want to add anything. I don't have much experience about how to get into robotics. Yeah, I do have one meta request though. I think I'd like to get through as many questions as possible. So maybe we should try and answer questions in 2 minutes or something. And then if we have extra time, we can talk more in detail.
Makes sense, sure.
Yeah. Thank you, Nevin. Meduri Asit Chaudhary, you can ask the question.
Hi, CS student. I have serious interest in robotics, and every time I think about that, there's a question which will strike my mind immediately. That is it possible finally to build an AI system which could make humans believe in it 100%? If yes, what would be the prime challenges we could face in doing that? That's my question.
I think Vikrant, would you like to start with this?
Yeah, that's an interesting question. So I guess the first thing is I want to point out this is not a robotics question necessarily. This is a question about the nature of intelligence in some sense. Can you what does another human being have to do for you to trust them 100%? And then now imagine like, what does an alien have to do for you to trust them 100%? And now imagine that this alien is like 100 times or 1,000 times smarter than any human. And now, like, what does this alien have to do for you to trust them 100%? Like, I think the answer pretty much comes down to like, you like nothing. You should not trust them, and you should instead have like a lot of trust in your methods, in like how you construct such a thing. Basically, if like a super intelligent alien came to you, like, you're screwed. There's like any test that you devise for like trusting them is something that they can also think of and evade. So it's more about, at least in like this human level intelligence and beyond regime, you have to have a lot of like, the short answer is we don't know yet. We have to build techniques that give us confidence in like how the intelligence is arising, and then also some confidence in how it will scale, and then kind of cross our fingers and hope for the best, is like the current state of affairs. Maybe your question was more about the kind of subhuman regime of like, robots today, and like how you would get trust in them. Yeah, I think Nevin can answer that.
So okay, so I think your original question was, can you distinguish humans from robots, and what does the robots have to do to imitate humans reliably? So an interesting thing is that in a lot of robotics projects, what you see this distinction that there is a clear distinction between how a human would complete the task and how a robotics project or a robot would perform the task. So one thing I can immediately came to my mind when I heard this question was that so one thing that is being solved right now is autonomous driving, right? Everybody wants safer, smarter cars which that drive very safe. And the gold standard for the longest time has been humans. You want your cars to perform as close to human behavior as possible. But I think the state of affairs, the actual fact is that humans are great, but they are not perfect. There's a lot of flaws in how humans behave in situations where they need to make complex decision making. Humans are amazingly fast at doing complex perception and coming to and analyzing a lot of mixed heterogeneous sensor data, but humans are not necessarily great at making the best analytical decision out of the data that is already available to them. I'm not sure I understand. Oops. Sorry, folks, ignore the voice assistant. Yeah, it's not so smart yet, Okay, so yeah, and so what I was coming to say is that what the researchers or what we end up encountering was that we want to mimic humans up to some point, but beyond that, humans are not the gold standard anymore. And but when you operate in a self-driving space, what you want to do is for your car to behave reliably to other humans who are expecting a human driver. So you have to sort of be safe, but also imitate human driving behavior to some degree. And so there was this one specific problem statement that we were discussing in class about merging behavior in highway traffic. So highway merging is one of the biggest problems that is that used to stop a lot of the self-driving algorithms. And the robotic approach or the analytical machine learning approach to solve it would generate very robust, very safe merging behavior, but which would confuse human drivers a little bit because they are cutting the margins in a way that a human driver would not do. And what ends up happening is that when you try and tune the algorithm to behave closer to the human data, you end up having irregularities in your driving behavior, and it is overall less optimal. So can we imitate human behavior? Yes, because you can just overfit to a human driving data set and draw more irregularities from it. But do we want to do it is the real question. And where do we want to do it? Where do we not want to do it? That's a very important distinction to make.
All right, thanks, Nevin and Vikrant. So, Tejas Ambore, you can ask your question now. Hello, Tejas.
Uh, yeah, I'm audible.
Yeah,
Yeah, like my question was, what would you prefer more, like reading books or opting a structured course? Because you have mentioned a lot of books in your presentation, which people of our age generally not prefer these days. So, what would you suggest to someone who's trying to develop a mindset for research?
So if I understood your question, it's you're asking, should you spend time on writing code or should you spend time on reading stuff? Is that right?
Yeah, like preferring opting a course or reading stuffs from books.
I mean, I guess the way I would approach it is, find some questions that really interest you, where you have a real curiosity or a real itch to kind of know more, and then just find the best resources for answering those type of questions and try to directly answer them. So in some cases that will mean, for robotics questions, for instance, very often it will come down to understanding the practical limitations of different kinds of hardware, or understanding, I don't know, communication protocols, or various robotic operating systems and things like that. If you were trying to answer a different question, how do neural networks see things, then you'd be doing a lot more of convolution neural networks and sort of GPUs and TPU programming and stuff like that. If you were interested in some mathematical question about guarantees for safety, or guarantees for control, then you'd be reading a lot more textbooks and building up more maths machinery. So yeah, I think it really depends on which questions you want to answer and what's interesting to you. If you don't know what's interesting to you yet, I'd suggest exploring lots, try lots of different things.
Okay, so for me, I think I did not have a very clear interest for a very serious interest for a longest time. I think what helped me was the second approach, that I was an avid reader. I had lost my reading habit for a bit, but then it came back to me the more I got bored. So I would recommend reading books that you don't have 100% interest in. So if you just stick to what you already like, then okay, that's good. You're learning more. But I would also say that you should read books that are tangential to your interest. And um, how do you know about these books? So one thing to find out more books is to one, Google. You can be a self-starter and find out every related tangent field, and find interesting books that are recommended by people. Another way that I think is seriously underrated, or at least people forget about it, is to stay connected with the people in similar areas and trying and talk more with people working on things that you're interested in. But no two people are the same, right? So somebody who's interested in similar fields will often come to that field from a completely different angle. So they might be interested more about the let's say robotics, right? The people who end up doing robotics come from computer science, come from mechanical engineering background, electronics, embedded engineering background, or even production products background. Yeah, so they have a specific reason they came here for, and they will have come to it from a completely different angle. The background knowledge that they have, the books that they've read will be different, but that somehow motivated, culminated in their interest in the same particular field that you are. So then that means there are a lot more tangential fields that they already know about that you don't know yet. So I would recommend very strongly in actually talking to people who are interested in similar areas. And yeah, so I think the people that I've met in KGP and the network that I have um, been dropped into in KGP is a big motivating factor in me eventually end up rediscovering what I'm really interested in. And yeah, and I would definitely recommend reading more in tangential lines to your interest, because that is often how you come across really fascinating things that you didn't realize that you had so much interest in. So, yeah.
Yes, so in this question, I wanted to add one more thing. Like, I really wanted to ask for any research work, or if we think of a problem statement, uh, I have seen that there are two kind of people. One who work through their intuition, or who have read many books which are not directly related to this particular research area. Like when I read Homo sapiens, or like these kind of books, there is something in my mind always there whenever we go for any problem statement in data science or AI, or any intelligence problem statements. Somewhere some dots get connected from that book, or from these kind of books. So have you have you able to, like, have you ever do that, like connected the dots from the books which are not directly connected to these particular areas? Like the book is not related to artificial intelligence or anything, but that helped you to build your intuition in that particular thing, and help you to sustain in this area more, to think more.
It's funny that you should mention Sapiens, because that's one of the books that really got me back into scientific curiosity a little bit. Sapiens and its sequel, Homo Deus, both by Yuval Noah Harari, are excellent books. They are not strictly scientific, but they explain the evolution of human nature and civilization and scientific curiosity from a very logical perspective, historical perspective, and trying to reason its way into a lot of its conclusions, and which I found very fascinating. So I think I cannot point to like a very specific research goal that I was able to meet because I read the book, but it got me thinking about a lot of different tangential interests that I had, and partially got me into reading more about these areas. It got me reading more about AI, about robotics, about what the current state of things are. And so that's what I was talking about, that the books don't necessarily might not help you in giving the exact solution to the problem that you're looking for, but they will open up your mind about a lot of related fields. The books themselves do, and tangential books open them up even more, and it's helpful, even to talk, even to understand the problem set a lot more. It's helpful to have an additional reading that you did, which will help you talk more about those things and connect to more people. And yeah, I highly recommend reading Sapiens, in particular Homo Deus, which is a lot more relevant now. Yeah, I can't think of any other books at the top of my mind, but yes, thumbs up from me for those books and reading it, even if they are not directly related to what you're doing today.
Yeah, I guess I would just echo that. I mean, this is the reason why there were so many books in my talk. I would say I've had like a ton of fun just like reading the craziest ideas I can find. For some reason, that's like really exciting. And yeah, just it turns out later that some of those ideas are, if nothing else, you just you need some like fuel to kind of motivate your curiosity and keep hammering away at a question that's like very difficult. And so if you keep yourself excited about it, one good way to do that is by reading lots.
Yeah, thanks. We can take next question.
Sir,
Rohan Gupta.
I am first year from electrical department. Sir, joined recently. I have interest in robotics and drones. What I need to start with, and how I need to start to excel in this field.
Okay, yeah, I guess that's the question for me. Again, like I said earlier in the talk, there are lots of resources in campus about lots of societies in campus which do exactly this in robotics, and you can join any one of them. It really doesn't matter if you are interested in quadcopters and you join the ground vehicle team, because a lot of it is about like if you want to progress further in robotics, then you need to get a feel for what it's really like to work with physical robots and what are the challenges involved with them, and really understand if you're interested in the whole of robotics or if you're interested in a subsystem, if you're interested in more in AI or machine learning or control systems, or the whole of robotics, right? It's a very broad field in the sense that it has a lot of different disciplines within it. And the easiest way and the hardest way is to just start working on an actual real live robotics project and understand and narrow, fine tune your interest so that you can quickly go in the direction that you want. So I would definitely recommend involving with an actual project that is already up and running, and then going from there. So then you can fine tune your interest, and if you're really interested, you can take courses that are related to what your interests are, or you can try and work more in the narrow field of your interest, develop toy projects, and yeah, so it really depends on what is your specific interest within robotics. And um, yeah, there's so many opportunities in campus that I think for to meet all your undergraduate research interest in robotics, KGP is actually well stocked.
I think Nevin has covered all the points. Rohan, you can ask question.
So one big point is that I think a lot of people struggle in understanding the value of the things that you do in campus. I really want to reiterate that having a top CGPA is not the only way to get into a good education program. And I think both me and Vikrant can relate to that. Both of us, I don't think I can speak for me. I was not really that great at academics, and I was not also interested in, like, I was not really interested in what I was working on my thesis as well. But I was really active in the areas of my interest, just autonomous underwater vehicle society and TLS, the Literary Society. So it doesn't really matter how you perform on an academic scale, as long as you have an interest, you pursue that interest passionately, and you can quantify that, okay, you have made use of the opportunities that you had in this area, and you've done your best. And as long as you're able to demonstrate that in some fashion or any fashion, um, yeah, opportunities will open up for you if you want to do higher education or if you want to pursue a career in the industry. As long as you have a strong interest and a demonstrable anything, a project, a experience, or a something that you wrote, a blog, things will open up for you. So don't be too stressed about academics is what I'd like to say. That said, don't let your academics go, but your life is not defined by the CGPA. I think that's a thing that a lot of people in KGPA miss until it's a little bit too late.
Yes. Rohan, you can ask the question now. I think he's having any some problem. Matthew, you can ask now.
Hello, can you hear me?
Yeah.
Hello, everything's audible and everything's all right. Yeah, I'm Matthew. I'm from biotechnology department, but even still, I do have a bit of interest in the electrical side. More specifically, I think you must have heard of a company called Boosted. It is a company of electrical skateboards, right? I think you're very familiar with that because you are good in that area. So just this crazy idea like popped up in my head like during my 11th class. Like well, I mean, now that company has just gone downhill, but even still something along that lines, I would try to do that when I am in the campus. So any suggestion, any tips on how do I get started? And I also have this one more crazy thought, like there is a thing called hoverboards and all that sort of stuff. It's like totally stupid, but even still, since you are an expert in that field, I thought I would just take your advice on such stuff and all those sort of things.
Okay, let me try and understand the question. So the first question is about boosted boards.
Yeah.
If the app is viable, if it's really going to work out soon in the future or not.
Yeah. I mean, I
And
want to work in those lines. So, what would be your suggestion? Where should I start? It is like a big place. It is like something really big, and I would like to try and do like motorized vehicles that go on the ground. So, like, if I would like to start in those lines, where would I start?
right, so I think boosted boards is not specifically a robotics company, but they are a product company which develops specific products, which is the powered skateboard.
Yeah.
And so that's not strictly in my domain, but again, so you have a very specific company that you want to go for, you have a very specific problem that you're interested in, that's great. What I would recommend is you try and understand. So I mean, the way that I go about focusing on a company or a job profile is I do the dumb guy approach. I just go to the company, Google about what they do, read a little bit about them, then go to LinkedIn, go to the job board on LinkedIn, and look at what roles are open in my domain. And I try and look at what are the required competencies that they expect somebody for this role to be in. And then I try and develop my profile in a way to fit those gaps. During this process, I either discover that I am not interested in this company anymore because the problems that their engineers work on is not of interest to me, or that I lack something in this particular field and this is something that I want to develop. And and then again repeat the process when I build more skills, try and repeat the process with other companies and see how I build myself. So so I'd recommend that is similar. That is what you do if you are very specific about the job role that you want to get to and the company that you want to get to. If so, I understand that Boosted is not a company in India. So if that is the direction that you want to get to, but you cannot immediately pursue that after graduation, I'd recommend that you look for similar roles in smaller companies in India, and then build some experience and then directly apply. You'll be surprised at the reception that you get if you have a very specific targeted profile, and that you have a specific avid interest in going to a company, that they'll be very receptive of you as long as you have the competency.
Yeah, beautiful answer. Thanks for cooperating with my kiddish thoughts. Well,
All right, so you can ask now.
Yeah, am I audible?
Yeah.
Yeah, okay. So this is Shubham Chakraborty. I'm a second year undergrad from electrical engineering. So like this is from a person who has a lot of interests. So like I was confused about what to do with like all those interests I have. Should I go like one at a time, or should I try to take them together? Like what would be your suggestion? Because I think focusing on one interest, like it is the common notion that focusing on one interest, like really focusing on it would lead to better outcomes. But like, so what to do in this case?
I can take a stab at that. Yeah, I also feel like I had and have a lot of different interests. I think for me it ends up being like I don't know, from time to time, like one of your interests will just grab you, and then you'll feel like spending sort of 2 weeks or 1 month just like really going deep into that one thing. And other times, like none of your interests will grab you, and you'll just be sort of not that motivated and looking around for different things. I think both those states are fine. The important thing is like when you do have like a lot of energy towards something, uh, you should really go for it. And if you have to spend all nighters or kind of spend more time working on your project than like doing social things or whatever, like do it. Like you have to, I don't know, really like uh, put something at stake basically to like learn and grow. Yeah, and like when you're not that motivated, do lots of exploration. Like just try to find sparks for different ideas. Talk to lots of different people. I find often a good way is like to find someone smart that you disagree with about something, and then go and talk to them about the thing you disagree about. Or go and talk to somebody about ideas. And yeah, also like don't punch below your weight. So like a common failure mode is people think, oh, I need lots of preparation to talk to somebody, or I need to study a lot before I can like apply for this thing. And the truth is probably you don't. And even if you did, like you wouldn't know what you need to do or how you need to prepare unless you tried. So it's like really important, especially if you're like afraid of something, do exactly that thing. And then you'll like learn lots in the process. Yeah, that's kind of a rambly answer to your question.
Yeah, I have similar thoughts. I'm also a big proponent of just reaching out to people, and I think the more time you spend after graduation, that I found that people are really interested in talking about shared interest. Because I think once you graduate, what you will end up realizing is that the world outside is not same as IIT Kharagpur, where you are on a daily basis interacting with people with your narrow set of interests. So yeah, so that means that when people do find people with similar interests, they're happy to talk about topics. Shared interest, right? So I really recommend reaching out to people with who you think have interest in similar fields, and just having a talk. Again, like Vikrant said, don't worry too much about what you don't know, because just an interest is quite sufficient in some points. They'll be able to tell you, if you have an interest in something, they'll be able to tell you what is the general direction that you can go, what are some things that you can do, some things that you can read about, some YouTube videos that you can watch about, and then you'll have a much easier time educating yourself in that field. And you'll be able to always go back to them and have a more informed, involved conversation about something. So don't hesitate to reach out to people and talk about your interest. Yeah, that said, yeah, if you don't have any personal connection to them, I would recommend doing some reading up about it, and be very upfront that you either want to talk on a very specific topic which you are knowledgeable about, or that you want to build, you want to know on a very specific topic, so that the other person is also aware. So that's just an interpersonal thing that you have to work through when you talk to somebody who you are not already friends with, right? That you want them to know what is it that you really want from them. And yeah, so you want to have a plan and structure to your conversation rather than just saying hi and then trying to figure out where to go from there, right? So yeah, but people are generally receptive if you want to talk about their interest. It's just that you have to be smart about how to approach people you don't already know. That's it.
Yeah, thanks, Nevin. Rohan, if your issue is solved, you can ask now.
Hello.
Yeah, you are audible.
Hello. So I think I have a pretty lame question, but I was really curious about that. How do you earn as a researcher? Sorry if it is pretty lame, but I was just curious.
So I can speak to the academic side. So okay, so if you want to do research, it doesn't necessarily have to be through academic side. So Vikrant is working as a researcher. He's working for a company. He has a regular salary, so that's he's literally earning. So about the academic side, which I believe is what you're referring to. So if you are pursuing a PhD, you have a stipend, which is identical to salary in a lot of regards. You are getting paid to literally do research. And also, so if you look at what the stipend amount is and what an average salary of let's say IT professional in a similar field is, there's a lot of disparity. But then you also have to account for the fact that you don't have a lot of expenses. And you don't pay taxes. So like, if you're asking a financial question, I'll give you a financial answer. You don't pay taxes for a lot of it because you are working for an education institution and they are taxed differently. And yeah, and a lot of your expenses are taken care of by the lab. Your living expenses are already pretty low. You might be able to get on-campus housing, which will again cover your expenses. Your food options, the money you spend on food will be low because on-campus subsidized expenses. Everything is subsidized on campus because of education discounts. So yeah. So if you are really interested in research, I don't think earning potential is going to stop you. Should stop you, or doesn't? You don't need to worry about it. It will take care of itself.
Yeah, I guess I'll add something to that. So I think the people who really succeed at research or like to really enjoy research, the expected amount that you learn is less in research than the expected amount if you went into like making products, for instance. So like people who are really motivated by like earning lots of money, like research might be like a bit disappointing unless you happen to be like one of the lucky ones who gets like a high-paying research position. But there are not like that many of them. Having said that, like research does give you like a comfortable enough salary. So if most of the joy you get from your work comes from like thinking about these questions, and then some of the joy is from having like a few comforts, then it's fine. Like it's enough for that. Yeah, I guess that's what I'll say. The other thing is, there's lots of different ways, I guess, to earn as a researcher. You can get grants for things. You get like scholarships and stipends when you're doing your PhD. Later on, if you decide to go into academia and become like a professor or something, then professors earn pretty good salaries, at least abroad. My sense is like it's not a good idea to become a professor in India, but yeah, but like probably I don't have much experience with it. Maybe somebody else has a better opinion. Yeah, certainly if you become like a tenure track professor or something at a university, that's like really good. And then a lot of researchers end up doing paid stints with industry, or they end up working for a company directly. Like all of the people at DeepMind, for instance, are doing that, or like anybody working at Google Brain or Google Robotics are all earning like Google salaries. So that's like amazing. And it depends on like what, like for I guess for AI and robotics in particular, there's lots of jobs in industry, and lots of demand for PhDs in these fields. Not just AI and robotics, but also like statistics and physics, and basically people look for anybody who has done some kind of quantitative PhD, or some kind of like STEM PhD, and there's a lot of demand for people like that in the industry. Now the flip side is that you might not end up with as much freedom to like exactly think about the questions that you care about the most, but there's always that option at least. And so yeah, I think as a researcher you have to be like pretty flexible.
Yeah, so guys, Vikrant would be leaving in a few minutes. So those who have any question unrelated to his research, please unraise your hands. And those who have a question for him, please keep raising your hand.
Hi, I'm Hashit. I have one more question, and this is for both of you. Let's say we are finally somehow able to build a robotic system with like AI and connected that can mimic a human completely. Let's say we are able to do that in future. Generally, we humans, we don't believe persons who are too smart. We can't trust them more than more than a extent. The persons who are too smart, we can't trust them to the complete extent. And if robots with AI which mimic humans completely, they also think like us, and since we made them, they will definitely think we are smarter than them. I think so. And if they lose trust in them, how could it be solved, and what would it result? Am
Yeah,
I clear?
I'd like to take a stab at answering this. So I guess one thing is like I don't really understand why you would think your creator is smarter than you. So for instance, humans arose through natural selection. I think natural selection is pretty dumb. Like it has basically zero intelligence. It's like the dumbest brute force brute force process that you can imagine. And yeah, it gives rise to like incredible amounts of complexity, and obviously to us. But that doesn't mean like I would, trust it to drive a car. Like obviously it's going to fail at that. It's like pretty dumb. So yeah, I want to like draw a distinction between like the optimization process that leads to like a particular intelligence versus like, like, I don't know, something like being smarter than you. These are like two separate things. Yeah, coming back to the first thing about human mimicry. So I guess another point I would make is like, you said like we don't trust people who appear too smart. But if someone is really smart, then they're not going to make the mistake of appearing too smart, right? Like that's. I mean, there's a reason why politicians who are really good at pleasing lots of people and getting lots of votes don't try to sound very smart. They try to sound very folksy and approachable and friendly. Even though the same politician, if you see videos of them, in back rooms with industrialists, will sound very different. So there's like a whole art of being persuasive and convincing, and I expect that if humans can do it, then so can AI. But and a third point I want to make is like I guess the fundamental limitation of mimicking humans is going to be that whatever our flaws and biases and weaknesses are will also get passed on to the AI and the robot. And this is not necessarily what we want. So for example, if we want to build a rocket that gets to Mars, and like imagine like we're not able to do it, like as a civilization we're not smart enough for some reason. We don't really want to build an AI that just mimics our ignorance and stupidity, right? Like we want an AI that understands our intention and then fulfills our intention in a more capable manner than we're able to do. So this is always going to be a fundamental limitation of imitation. I guess the reason imitation is popular is you have lots of data for it. So it's quite hard to imagine, how to build how to like drive a car from scratch. Like if you didn't use any human data at all, you would need like something that was able to reason in a very intelligent way to drive a car. But by contrast, it's much easier to look at hundreds of thousands of hours of human driving data and then just learn to copy that. And then like in the 1% of cases or whatever that humans make mistakes, you do better than humans. So automatically you have a system that's like 1% better than humans, for example. So imitation is used more as a data efficiency trick rather than like the goal of AI.
Great answer, first of all. Yeah, the first point was what got me that. I mean, you have a biological imperative to think that somebody who's older than you, who gave birth to you, is wiser than you in some way. But an AI developed with analytical methods built on solid reasoning, which is what programming is, will not necessarily think that just because it's older than me or something created me, that it's necessarily wiser than me. You can ask the counter question that if I was created, and then why, if they could already solve all the problems, then why was I created? Why did they have to create an artificial intelligence? Because yeah, that's another question, right? So again, this reminded me of another a book that I read a long time ago, a science fiction book that has nothing to do with, I thought had nothing to do with AI. There's a book called Mutation by Robin Cook. I was just Googling up the name right now. So that book talks about genetic modification, and this doctor created a superhuman, super intelligent child in a lab. And what ends up happening is that the kid is amazing, can play like chess at 2 years old and beat grandmasters and blah blah blah. And then at age 4, he decides to play dumb because he realized that people realizing that he's super intelligent is a threat to his autonomy, and is like putting more restrictions because they're afraid of him. So yeah, if you are interested in this whole situation, if you want to read more about more data points from a fictional perspective, I recommend reading Mutation by Robin Cook. It's not a great book. I would not recommend it to anybody else without an interest in this.
I would recommend Flowers for Algernon as a great book about what being highly intelligent at the human level probably looks like. Yeah, That's quite good. There's a similar book by similar short story by Ted Chiang called Understand. So if you don't have the time to read a whole novel, Understand is a short story that you can read. It's by Ted Chiang.
Okay, thank you.
Thank you, Vikrant. Milan Madhudas, if you have any question, you can ask.
Am I audible?
Yeah, you're audible.
I had a question for Vikrant. I just wanted to ask, how do you check when a complex AI system misbehaves? Like I can remember also a situation when a DeepMind, you guys at DeepMind were training an RL agent to play Tetris, and it just paused the game so that it never loses.
Yeah, exactly. So I think there are a lot of different ways in which an AI system can misbehave, but basically they all boil down to in your training process. So there is a training process firstly. So the way these systems are being built right now is you have some kind of black box neural network. So you stick together like a CNN and an RNN and a MLP in some like architecture, and then you train it using gradient descent. And the optimization pressure is in the direction of some decreasing loss function. And the way you define this loss function, like I guess like when you think about this whole optimization process, there's like one thing which is like in the programmer's mind, there's like an intended goal, right? So for playing Tetris, the intended goal in the programmer's mind was this agent should be good at sort of playing Tetris. But the actual optimization process that they ended up implementing and this network was optimizing for is not playing Tetris well. The actual optimization process is make the value of reward in this particular cell in memory be high, right? That's the actual optimization process. You can think of it at an even lower level in terms of like atoms and molecules, but I won't go there for now. And then this optimization process is literally just trying to optimize that thing. And in this particular case, that optimization process figured out that there are like bugs in the Tetris simulator, so that if you press keys in a certain way, then the simulator will kind of just pause, or it might give you like lots of points for no reason. And so of course the optimization process is just going to go for that. It's not like thinking in terms of intended objectives of the programmers. Like you set up an optimization process to like maximize some value, and it's going to succeed at doing that. And like if that optimization doesn't match what your intended goal was, that is like a fault of you and not of the optimization process in some sense. So because of that, there are lots of different ways in which this optimization process can go haywire. So this particular thing is called sort of reward hacking, where it figures out like a way to get high reward that was not what you intended. But there are lots of other ways. So, for example, the AI process might it might like you might have like somehow misspecified the goal. So you you were trying to do something very complicated, like driving a car, and you didn't really know like how to encode drive a car in a mathematical sort of expression that you can minimize. So instead, the thing you encoded was avoid collisions and get people to the destination on time and keep a certain distance from other cars. And like you just have a bunch of clauses like this with different weights on them. And now you're hoping that this proxy for drive a car properly is going to like in fact work out. And it's entirely possible that you just forgot about some situation, and in that situation the car executes all of the clauses in your specification perfectly, and it just ends up leading to a horrible accident because the thing that you specified was incomplete. So that's another way in which it can go wrong. A third way in which it can go wrong is misgeneralization. So what I mean by that is like often these systems are put into situations which were not encountered in training. And then a kind of key question in AI safety is what will the system do in an unknown situation? And we basically don't have like good theoretical ways of thinking about what the system will do. So for example, let's say you have a system trained to play, Tetris and a bunch of other like Atari games. And now you put it in front of like an actual car, and you hook it up in like a similar way, so the input space is shared. So you still have like some video feed, and you still have some controls, but the dynamics of the environment are extremely different, right? Like an Atari game is like sort of pretty discrete. You press left and the pod goes left one square. But when you're driving a car, the controls are like much more complex, and the feedback loops are much more complex. And so this is a totally novel situation for this neural network. And now you're asking, like, what will it do? And one option is, maybe it will just break. Maybe it'll just like start outputting like haywire actions, and like it won't do anything. It'll just like look like a sort of random broken agent. But a different option is that maybe it will generalize, but not in the way that you expect. So maybe it will like drive this car very forcefully with a lot of acceleration directly into a building. Because, for some reason, the way it reasoned about this new situation is like coherent enough to do impactful things, but not sort of generalized enough to actually do the objective well. So that's like another type of risk. Yeah, there's a whole load of them. If you're interested in this, you can email me and we can chat about it.
Okay, thanks.
Great answer, by the way, but I just want to make a quick point. If you want a more illustrative understanding of what Vikram was just explaining, there is this YouTube channel called 2 Minute Papers, like 2 Minute Papers, that you can go to. And so a couple of videos that I'd recommend is just Google 2 Minute Papers, AI plays hide and seek. It'll lead you to a bunch of videos. So you'll be able to see what is a real example of what it means to train an AI in a simulation and fail by not specifying the reward correctly, or the AI figuring out a bug in the simulation and exploited that bug, and so on. So yeah, it will give you a very good understanding of what exactly he meant by all of that.
Yeah, cool. Okay, I'm going to have to jump off now, but yeah, thanks everyone.
Yeah, okay. Thank you, Vikrant and Naveen, for your valuable insights and time.
Feel free to message me on LinkedIn if you have any, if you want to connect. Or yeah, that's it. Thank you.
Yeah, thank you for your time.
Bye. See you all.
Yeah.